So last week we talked about truth tables. So truth table would show you a relationship between function and its binary variable values. Okay. So we have to evaluate truth tables or draw the truth tables looking at the operator precedence. So the operator precedence for Boolean expression is given here. So you have to consider parenthesis first and then not and or. Okay, keep that in mind. And then about min terms and max terms, I think we need to have a quick revision of these things, mainly because we will be using this in today's lecture. So what is a min term? It's an n term of the n variables, with each variable being primed if the corresponding bit of the binary number is 0 and unprimed if it's 1. So if you look at this, x and y, the mean term of the value for the value 0, 0 is x dash, y dash. The n term of the n variables, 2 variables, with each variable being primed if the bit of the binary number is 0. So it's primed mainly because this is 0. Okay. Since y is 0, y is prime. So x dash, y dash is the mean term corresponding to 0, 0 value of xy. So likewise, if x is 0 and y is 1, the mean term is x dash y because x is 0 here. And for x and y being numbers, the values being 1 and 0, so the mean term becomes x y dash. So it's a kind of opposite in max term. It's the O term of n variables with each variable being unprimed if the corresponding bit of the binary number is 0 and prime if it's 1. Okay. So, so this is the O term. So you can see in this picture, in this table. So we get the O term of x and y. And x and y are primed only if the values are 1. It's opposite from what we have done in min terms. In min terms, it is primed only when values are 0. Okay. In max terms, it's the opposite. We prime only if the value is 1. You can see here the value is 1 and y is primed. Here the value is 0 and y is not primed. Okay. So that's the normal procedure we do. So after you start identify max terms and min terms and know how to form a max term or min term according to the corresponding value of a variable, a set of variables. So now we can write Boolean function for a given output of a truth table. Okay. So that's what we discussed last week. So there are two outputs given here, and you are asked to write expressions for the two outputs F1 and F2. Okay, so F1 is written for you, and F2 you have to write. So if you look at F1, so you are asked to write the min terms. Okay, so you can see here min term F1. So for F1 to write the min terms, you have to consider all the ones. And the corresponding variable values, x is 0, y is 0, and z is 0. And since x and y are both 0, we have to prime x dash, y dash. And here we have x is 1. We have x is 1, the other two are zeros. Okay, y and z are primed mainly because these two values are zeros. Okay, and after that, in this corresponding column, row, we have x and y and z all ones. So no variable is prime here. So likewise, we can write the min term for function f1. Okay, so for any Boolean function, we can express it as a sum of min terms like. So you have to consider there are two ways. You can write a function by a sum of min terms, or you can write a function by a product of max terms. Okay. So when you are considering max terms, we are considering zeros. Previously we considered ones when you are considering min terms. When you are considering max terms, the opposite we do. In the function, we consider zero rows. So here we do the opposite. We we are writing the max term. So when you are writing the max term, when the value is 0, we don't prime. If the value is 1, we prime it. Okay, so let's have a look at 1. So this is the function value. So this should be x o y o z. However, since the values are zeros, we are not priming any. So this is the first max term corresponding to the first row. Okay. And here f1 value again is 0. So we are considering the corresponding variable values. And here we have 1 for y. So we need to prime that according to the definition. It's better to write the definition in books if possible. And the other two are also written accordingly. Okay. So likewise, so there's an exercise for you to do the same for function f2. So what would be the expression with max terms for f2? So there's an example, and I think we discussed this example. So there also you have to do the same, express the Boolean function. Either you can use min terms or max terms. Okay. If 3 can be written in both ways, which is correct. F3 can be either written as a sum of min terms or a product of max terms. Okay. So this is called sum of products form, SOP. So this is called product of sums, or product of sums. So today we are going to look at another form, which is called the canonical form. So in canonical, if you are asked to express any function in the form of canonical form, what does it mean? It means that you have to express it as a sum of min terms or product of max terms. Okay, those are the two canonical forms. These two actually. If you are asked to express f3 in canonical form, it means either as SOP or POS. So here, so without so this is how for a given function by the truth table, how to represent that as a Boolean function. Okay, so that's what we see here. Here we are looking at how can we convert a function into canonical form, given function. Okay, so this function given here, it is not in currently canonical form. So when we want to convert it to a canonical form, there are two rules for that. The first one is we have to include all the variables of the function. So in this function, how many variables are there? A, B and C. So they are the variables In the first term, you have only A. However, if you look at min terms and max terms, in each and min and max terms, we should have all the variables. In each term, we should have both x and y, both x and y, both x and y, like that. Okay. So here in this truth, here what we are asked to do is convert this into canonical form, and they have specified the canonical form as a sum of min terms, sum of products form. Okay. So, so what are the two things we have to consider? We have to have all the variables in each term. So that is one thing. Okay. And we have to convert this into sum of products form. That's the second one. SOP form. And all variables should be there. All variables. Okay. So those are the two major requirements. So that, how can we achieve that? So in the first term, A, you can see two variables are missing. Term A is missing two variables. The first term A is missing two variables. What are the missing variables? Can one of you tell me what are the missing variables in the first term? Can one of you tell me? Can Nisali tell me? Nisali Himansala? What are the variables missing? What are the variables missing? Or anyone else? Can one of you unmute and tell me whether you hear me?
Yes, madam, we can hear.
Okay, in the first term, what are the variables missing? B and C. You have A there, B and C are missing. So we need to include that somehow to that term and make this expression as a sum of product form. Okay, so that's our target. So the first term, in the first term A, it is missing two variables B and C. Okay. A equals A dot B plus B dash. So we can write, we have to include somehow the two variables. So we are using a trick here. So A is not changing if it's multiplied by 1. Okay. A equals A dot 1, value 1. Okay. So using this, 1 can be represented as this, which should not alter the value specified. Okay. Because the value of B or B dash equals to 1. Okay, so that we have studied. So put in this value, the variable A's value, the term A's value is not changing. So we use a trick to include B into the term A. And then we expand that. And so that's it. Okay. So now we have included term B also to the first term. So now we have replaced A with this. A dot B plus A dot B dash, which does not change the value of that corresponding variables. Okay. So after that, we need to include C also to this term. Okay. So for each and every term, we multiply C or C dash. We include it here as well as here. So that's what it has done here. So many people go and come, it's quite difficult. Okay, so what have we done? So term A is missing variables B and C. So we are trying to include those because in each and every mean term, it's a rule that it should include all the variables in the equation of the function. Okay. So to convert the first term into its min term, we have to include the other two variables. What are the other two variables? B and C into that. So how can we include that? So we use this truth. Okay. A is equals to A dot 1. It doesn't change. Okay. So 1 can be replaced by B plus B dash. Again, it doesn't change the value of 1. So this should be done. So after that, when we expand again, we can see in these two terms, C is missing. Then we can include that C again by including C plus C dash, which again does not change the value. So this term is multiplied by C plus C dash and by C dash C dash, C dash, C plus C dash, AB dash, the second term is again multiplied by C plus C dash like this. Okay. So after that, when we expand, you'll get the term like this. So now we have included B and C to term A, and we have ended up with having something like this. Okay. A, B, C, A, B, D, C dash, A, B, C dash, A, B dash, C, A, B dash, C dash. Okay, so what did we do? So we wanted to convert this into canonical form. So in the canonical form, what does it mean? So you have to write this as a sum of min terms or product of max terms. So in a writing sum of min terms, our target is to first write it as a sum of min term because it's asked here. So we get the first term. So you can see the two variables are missing. To convert into a min term, we have to include all the variables in each and every term. So in the first term, we have A, two variables missing B and C. So how can we include that? We consider this truth, A and 1 equals to A, so that so because of that, we can include instead of 1, B plus B dash. Okay. So we can include B plus B dash here and then expand like this, A dot B plus A dot B dash. So again, if you look at this term now, it includes B, however not C. So we need to include C as well to these two terms. So for that, we can include something like this, C plus C dash. So it does not change the value. So then we can expand and it would give you the term like this. So that's for the first term. For the second term, you can see A is missing. So you can do the same. So you can add as so you can end with A plus A dash. So after that, you can expand that and include it here. Okay. So so you can see this term is common, this one and this one. So A plus A equals to A. So you can write this expression, not repeating the same twice. So we'll get expression like this. So this is the sum of min terms form of A plus B dash C. okay, or canonical form. So now you know how to convert any given expression into sum of mean term. So, so now let's look at how we can represent function as a sum of product of max terms. So here we use sum of min terms or SOP form. We call it sum of products. Okay. Now here we are trying to express a function as a product of max terms or product of sums. Product of sums. Okay. Or product of max terms. Max term is a sum, if you see. Okay. So max term, let's have a look at the definition of max terms. Max term is the O term of n variables with each variable being unprimed if the corresponding bit of the number is 0 and primed if it is 1. So like this, the term should be like this. Okay, that's O between the variables. It should have all the variables included. So we have something like this. So we can use convert the function into O terms using the distributive law. Okay, we can use this law and expand this like this: xy plus x dash dot xy plus z. Okay. So then after that again we can apply the distributive law: x dash plus x, x dash plus y, x plus z, and y plus z. And you know x dash plus x is 1. And so we can remove that and write the rest. Okay. So however, you can see these three terms. You have to follow the same rule. It should have, each term should have all the variables. X and y does not have z here. X and z does not have y here. Y and z does not have x here in this term. So that can be included by adding one which does not change. We add 1 here, add 1 here, and add 1 here. It does not change the value. Okay. So this 1, instead of 1, we can include z using a trick. Okay, now we have z term also in this corresponding equation, term of the equation. And we can replace 1 with y dash. It does not change the value. 1 with again x dash. Okay. So likewise, we can include all the variables like this. Here, the same thing. Because in the class, I ask you to do this and I help you to proceed. Because without doing with your pen and pencil, you will never learn this. Okay. I just talk here. And you are not at least responding to me. If I ask you a question, you send me private chats. Why can't you just turn on the microphone and tell me? I mean, you should do that. So you have to take your pen and pencil and try to do this. So let's see how you can proceed. So so this is the same thing which we have done. So we used distributive law to expand this, and we identified that this is equal to 1. So that is 1, and the other 3 variables are here. Other 3 terms are here. In each term, you can see 1 variable is missing. Here you can see x and y, however, z is missing. Here you can see z and x, however, y is missing. Here you have x and, z and y, you have x missing. So how can you include that? So that is done here. Get each and every term, x dash y, and try to include z term. So this does not change the value. So you have just added 1 here and replace that 1 with z dash. Okay, it does not change the value. And again we add 1 here and replace that 1 is y, 1 with y because y is missing in this term. We need to include y to this term. Okay, and then you expand using distributive law and you add 1 here and then you add x terms here using that 1. Okay, instead of 1 we can use x dash, which does not change the value. And then you can expand. So now you have got a set of terms which all have all 3 variables. Okay, so then you can combine them and simplify and you will end up with this. So that's how you can convert a function into canonical form. There are 2 canonical forms as a product of max terms or product of sums or uh, sum of min terms or sum of products form. So now you know a given equation, how can you convert into sum of product SOP form or product of sums form, POS form. Okay. So these are the 2 standard forms we are talking so far. Sum of products form. So you can see here sum of products, Boolean exponent condition and terms we call is product terms or 1 over literals each. And product of sums form. So you can convert any into product of sums form using the previous method we discussed. So if this need to be min term or max term, it should contain all the variables, okay, either complemented or uncomplemented. That is important. Okay. So let's look at simplification of Boolean functions. So as discussed so far, I have previously discussed about how can we simplify a Boolean function. So we can use Boolean expressions, those theorems and rules, and apply them and simplify. But however, it's quite difficult sometimes with some expressions. So here we are going to introduce a new method. Okay. So why do we need simplification? Mainly because in the computer and in circuits, when you are developing this corresponding algebraic expression, when the complexity increases, the corresponding digital logic circuit corresponding to that equation also increases, the complexity increases in the logic circuit. So to simplify the logic circuit, you should first simplify the expression. Okay, so that's the reasoning behind this simplification. That's why we learn this. Okay, computers are built up of these electronic circuits. So these digital logic circuits play a major role in computer. So you are looking at the architecture. So these methods are being employed to further simplify the functions. Okay? So algebraic expressions of a Boolean function can be expressed in many different forms, which are not unique. So as I discussed you, so it can be simplified by using rules and postulates and theorems. However, sometimes it's quite difficult. So because of that, we use a new method called K-map method or Kana map. Okay. So in this method, we try to minimize, so simplify the function using a table. Okay. So it simply looks like the truth table, looks like a truth table, but it's quite different. So we use max terms and min terms to represent each and every cells in these tables. So So in the K-map method, we draw the map for the table for n variables using 2 to the power n squares. So each square would represent one min term. So you can draw for max terms as well. So let's concentrate on min terms first. Okay, I think you can remember what the min term is. Okay, the two, if you consider two variables, you get the product and the variables are primed when the value is 0. Okay, so that's the rule. So keep that in mind. Remember that what a min term is. It's really important and required to understand this process. Okay, what's a min term? So it's the product of the variables and it's primed only if the value is 0. If a value is 1, it's not primed. So that's the definition. And there are rules. Adjacent squares always differ by just one literal. Okay. Squares are not allocated to the min terms at random. Movement of one square vertically or one square horizontally results in min terms associated with two adjacent squares differing only in single variable. So let's see how we can satisfy these conditions in this table. So it's a table something like this. Okay, for two variables, K-map would be like this. And for three variables, it would be like this. And four variables, it would be like this. Okay. More than this, it's quite difficult. So we use other methods like Queen, McCluskey technique. So here, this is a two variable map. You can see the variables A and B. Okay. So you had to put the values, possible values for A and B like this 0 and 1 and 0 and 1. So in two variable map, as I told you, each and every cell corresponds to a min term. Okay. So this is the min term corresponding to these two values. Okay. So you get the dot product of the two variables and the variables being primed if the value is 0. Okay, so B is prime because A is 0 and B is prime because B is 0. So the value here, the value represented here is 0, 0, 0, 0. In terms of A and B is A dash B dash. It's min term. Okay. And here what's the value represented? A is 0, B is 1. Okay. So what's the value represented? A dash B. Okay. Here, in terms of values, we have 1 and 0. So what's the value represented? A, B dash. Here, as values, we have 1 and 1. So what's the term? A, B, because none of the values are zeros. Is it clear up to now? Is it clear up to now? Can you please unmute your microphone and let me know?
Yes, madam.
Okay, it's clear now. You can develop a two variable K-map like this. So this is the two variable K-map. Okay. So similarly, we can develop a three variable K-map. However, you have to make sure you have put the correct combinations of B and C here. Otherwise, the whole thing gets very difficult to understand. There are several ways of writing these combinations. The rule is given here. Adjacent squares always differ by just one literal. So that's the rule. Okay. So you can see here and this term, the literal change only with one position changes. Okay. So here when you're moving from, so if you compare this one and this one, only this literal changes, not this one. This one is same as this. Okay, do you get what I say?
excuse me madam.
Yes.
madam මේ 3 variable map එකේදී මේ
Oh.
ඔතන variable තුනක් තියෙනවනේ මේ A B and C කියලා.
Oh.
ඒක මේ ඔතන truth table එකේදී ඒ කියන්නේ මේ map එකේදී මේ ලියන විදිය අනුව මේ වෙනස් උත්තර ලැබෙනවා නේද? ඒ කියන්නේ A B and C කියලා.
Oh, that's what I mentioned here. So there's a pattern you have to write, okay? So this is not the only way you can write, okay? There are 2 or 3 methods. I mean, there are 2 or 3 maps you can draw. So here, look at this. There's a rule. So if you get 2 adjacent cells, it can change only by one variable, okay? So here B value is 0. Here B value is 0. That value has not changed, okay? And C value is 0. C value is 1. It is changed. It can change by only one position. This only changed. When you compare this one and this, that also should be true. I mean, the rule is one value only can change. So here you can see C value is not changed. C value is common, so not common, same. But A value is changed. Okay, A value is 1 here. This is 0, this is 1. Okay. So when you consider these 2 adjacent cells, okay, it is for B you have the same 1. Okay, for C you have it's changed. It is okay. Only one position can change at a time. Okay, so that's the rule. You have to follow that rule and write. There are, I think, 2 or 3 possible ways of writing this in that way. I mean, following that rule. Only one variable that can change in adjacent cells. So that's the rule. So this is not the single format you can use. There is another format as well. So you can, I mean, change. This is 0, 0. Then you can go to 1, 0 here. Okay. Then 1, 1 and change it accordingly. So likewise, there are different formats. So however, I'm not discussing that here. I will discuss that in another example later. Okay. So at the point, don't be confused. If you use this format for the exam, you will be given full marks. Okay. So this is one of the formats which is correct. Okay. However, if you are keen, you can look at the other formats also. So I will discuss that using an example next day. So for today, since we need to introduce these concepts, so we may not make it very confused for the people who are not familiar with this. So we'll go in this way. So writing these values for each and every cell. So initial values is important as he indicated. So if you write wrong combinations here, you will end up with having a wrong map and a wrong answer. Okay, so that you have to keep in mind. So this is a 3 variable map. So likewise, we can draw a 4 variable map also here. So the same rule. So adjacent variable value should differ only with one variable. Okay. So after you develop this, write these initial maps, so you can proceed with your own problem. Okay. So here you can see similarly we can write the min term using the value corresponding to this box 0, 0, 0. So these are 0 values. So you have to prime it. So here also you have 0, 0, 0, 0. You have to prime the term. Okay. So this box corresponds to A dash, B dash, C dash, D dash. Okay. So let's have a look at a question, problem. So if you ask to convert a logical expression in the term of, you are asked to simplify a function using this K map. So there are 2 things you need to do. You have to convert the logical expression into sum of min terms or product of max terms. So So now we are considering how we can solve this using sum of min terms form. Okay. So our main target is to use sum of min terms form to solve this problem. Okay. To simplify this function using K-maps. Okay, we are drawing the K-map corresponding to min terms. Okay, there's a way of drawing K-maps corresponding to max terms as well, but now we are only considering min terms. For min terms which are present in the expression, ones are written in the corresponding square. So you know for how many variables are. There are 3 variables. So the map should be something like this. So you are writing only these 2 rows. So let me erase this. So this should be the initial map. So this is the initial map. Okay. So these values you, as it mentions here, min terms which are in the expression, ones are written in the corresponding squares. So for the min terms which are in the expression, if a dash, b dash, c dash is in the expression, we put 1 instead of a dash, b dash, c dash. So if in your expression, if you can find a dash, b dash, c, you put 1 here. Okay. So your initial map would be something like this with having nothing written in these places. Okay. Here you don't write anything, rather than you put 1 for the corresponding terms. Okay. So let's see, you write in your initial map, you only fill out these boxes A, B, C, and the corresponding pattern initial values here. So we have the first term is A dash, B, C dash. Okay. So in min terms, we prime only when the value is 0. So A dash should be 0, B should be 1, C dash should be 0. Okay. So what's the box corresponding to 0, 1, 0? 0, A, B, 1, C, 0. This is the corresponding box. A dash, B, C dash. Okay. So the second term, A dash, B dash, C. What's the corresponding values? 0, 0, 1. Okay. So we get 0, 0, 1 here, which corresponds to A dash, B dash, C. Okay. And A dash, B, C. Okay. A dash is correspond to 0, B is correspond to 1, value 1, C should have value 1. So A dash 0, 1, 1 correspond to this. Okay. And then we have A, B, C, which have 1, 1, 1. Okay. So A is 1, B, C are 1, and we get 1 here. And this next one is A, B dash, C. A is 1, B dash is 0, and C is 1. And here we have that A is 1, B is 0, C is 1. This one. So now you have filled out the K-map. And then you have to look at what are the next steps to complete. So simplify this. Okay. So after you fill up the table like this, you have to group these whatever the values of ones you have got here. So there are some rules you have to follow when you are grouping items fill out in the table. So we recognize various patterns and combine squares marked by ones. So we make different patterns and combine in different ways to simplify this. Okay. So these are the rules. Every square containing one must be considered at least once. These squares should be considered at least once. Okay, so that's the first rule. A square containing one can be included in as many as groups. It's all right when you are grouping this. So we are trying to make groups of ones. So when you are grouping, you can consider one value more than two group, one group, more than one group. It's all right. Okay. You can consider a value common to two groups. It's all right. Group must be as large as possible, and the number of adjacent squares in a group must be equal to 2 to the power n. So, such as 2n equals 2, 4, when n is 1, 2, 3, 4, 2, 4, 8, 16 likewise. It cannot be 3, 5, 6, 7, 9 likewise. Okay. So, you can make group of 2, 4, 8, likewise 16, likewise number. It cannot be 3, 5, 6, 7, 8. The map is considered to be folded or cylindrical. You can consider this as folded. What is that? You can consider this map as folded. You can think this whole paper is folded like this. And if you combine these two arrowheads, it is folded into a round cylinder like this. Okay. So cylinder like this. The two edges here and here are combined into a cylinder like this. Either this way, or you can combine these two as well. So this is a horizontal cylinder. If you combine this corner and this corner, it would be a vertical cylinder. So this matters when you are grouping. Okay. So if there are two variables here and here, you can make those are in a single group like this. Assume that this is a vertical cylinder like this. So this is a vertical cylinder from this way and this way. You combine it and these two are in a single group in that, thinking in that. Okay. So let's have a look at examples, and this would be much clearer for you then. So construct the smallest possible number of groups, and it says group must be as large as possible also. Okay, it needs large, small number of groups which are large. Okay, small number of groups which are large. You should obey the rule 1. Square containing 1 must be considered at least once. However, there may be squares which contain 1 which is left. It doesn't matter. Okay, you can include that into the final expression later. So, each group of squares containing ones is equivalent to replacing all the minterms. So this is the simplification of groups later. So let's form some groups and try to proceed later. So you ask to simplify A dash B dash plus AB dash. So you can see here. So you draw the two variable K map here and you fill out the boxes. So how can you fill out the boxes? You put 1 when A is 0 and B is 0, both 0. A is 0, B is 0, you put 1, which represents this corresponding function. And when A is 0, A is 1 and B is 0 also, you put 1. Okay, so here 1 is put when A is 1 and B is 0. A1, B0. Okay, so likewise you can fill out the box, and you have to make groups of 2s, 4s, 8s likewise. It should be adjacent. It should be adjacent cells. So adjacent cells have value 1 like this. So you make a group like this. Okay, you have one group, it should be bigger as possible and small number of groups as possible. So now you have formed one group which contains all the variables. So how can it, so these are the groups or terms of your final simplified expression. So our main target is to write a simplified expression now. So what are the terms now we have got from the K-map? So they are indicated by the groups. So how can I write the simplified form? You have to look at which variable does not change the value. Okay. So in this group, the variable B does not change, however, A changes. Okay. So we get the variable which does not change and write the corresponding min term. Okay. We write the corresponding min term of the variable which does not change. So B does not change, it has value 0. So value 0 is common for these two terms or for this group, values in this group. So it is the min term of this group, or in other words, the simplified form of this expression. This expression can be simplified to this. So can you do, so that is it. So can you do this one? Can you fill out the boxes? You can draw this in a piece of paper and put ones in corresponding boxes. And then try to form groups, and I'll help you then. Okay, let's see how we can do this. So what are the corresponding values for these terms? A dash represents 0, 1, 0, 1. It should be 1 here. Tell me if I'm incorrect, okay? AB should be 1, 1. Here, AB dash should be A equals to 1, B equals to 0. So these are the three boxes that should be filled according to these three terms. Okay. A dash 0, B equals 1. Both of these are 1 and 1. A equals 1, B equals 0. Okay, so these are the three boxes that need to be filled. So now we have the challenge of making groups. So what are the rules? Every value should be in at least one group, and the group should be bigger as possible, and group value, the number of elements in a group should be in the order 2, maybe 2, 4, 8, like as 2 to the power n. Okay? N can go for 1, 2, 1, 2, 3 likewise. So now what's the biggest group I can make? How many elements can I include here? I can include 2 variables like this. And in the rules, it says I can overlap groups. So I will draw it like this, where one is overlapped in between the groups. Okay. So now we have made the two groups. So how can we write down the corresponding min terms? In this group, what's the corresponding min term? What is not changing? B value is changing. B is 0, V is 1 here. A is not changing, A is 1. Okay. So I write A here, corresponding to this group. And corresponding to this group, what is common, what is changing? A is changing and B is common. Okay. So the corresponding min term is B. How can you write the final simplified expression? By taking the sum of products, sum of min terms, A plus B. So this is simplified. Okay, any problems? Anyone need me to explain what we have done so far? Or do you understand?
Excuse me, madam.
Yes.
උදාහරණෙ madam B dash ගත්තේ දැන් වෙනස් වෙන්නේ B නේ.
Venas
A වෙනස්
A venas. මට තේරෙන්නේ
A
නැහැ.
උදාහරණෙ.
What's that?
ඔය ඔතන උඩ තියෙන example එකේ පළවෙනි
It's example 1 or example 2? It's example 1.
ඒකේ madam වෙනස් වෙන්නේ නැත්තේ B වෙන B dash ගත්තේ ඇයි?
Because the value is 0.
ඔව්.
Not change the value. 0. So when it's 0, the corresponding min term should be B dash.
හරි.
Okay.
Thank you.
Okay. Are there any problems? Others? Any other problems? No, any other problems? So let's proceed. Okay. So this is the answer for the we discussed. And you have another example. Can you do this? So this has 3 variables. So this is the pre-table, initial table with initial values. So you can fill out the boxes and try to develop the grouping. You can go for grouping and then write out the corresponding min term and then simplify the expression. Okay. So it will be something like this. So I think let's do it rather than showing this. So here we have 3 terms A dash, B dash and C dash. What are the corresponding values? A dash 0, B dash 0, C dash 0. So the corresponding box or cell which corresponds to 0, 0, 0 is C. So it is 1 here. And you have A dash, B dash, C. A dash is 0, B dash is 0, and C is 1. A dash, B dash, C should be here. This one. Okay. Now we get, it's really simple. You get the grouping as this. And here you can see A does not change. A value is 0. And B and C, what is changing, what is not? Hmm? Here you can see value B, 0, 0. It is also not changing. A not changing, B not changing, but C is changing. Okay, so how can you write the simplified form? A is not changing, we can write the value is 0, A dash. And B is not changing, so we can write B dash. Write A dash, B dash here. Okay. So this is the same, this is a single group. So what is the simplified form of this single form? Single group here. In this single group, what is the simplified form of the equation? A, B, A dash, B dash, mainly because A value is not changing and the value has the 0. It is A dash. Then if you look at the other two variables, what are the not changing variables? B is not changing, C is changing, 0 and 1. Since B is not changing and has the value 0, we write is B dash. So why didn't you sum this? Why did you put dot here? Because this should correspond to a single min term. So we are writing the min term here. Okay. So if there were two groups, they would be combined by a O. Okay. So this is and mainly because this corresponds to a single group. Okay, any problems? Seems no. So now we can proceed. So this shows you how this A dash, B dash is common to both pairs. So thus the simplified expression is A dash, B dash. So you have to simplify these expressions. So can you draw the truth table and put the corresponding values and try to do the grouping. Okay. Okay, I think you may have done this. So let's see. These are the answers for the first one. So first one is quite simple. It's same as what you have done so far. So do I need to explain this? I think we can go to the second one, isn't it? The second one, actually, the grouping is what you have to learn here is the grouping. In the first one, the grouping is quite straightforward. So here, the value in the middle is common to both groups. It doesn't matter. And when you're writing the group corresponding min terms for the groups, be careful. So the A value is not changing, it should be A dash. And the BC, from BC, you can see in the first group, B is not changing, C is changing. Since B is not changing, it has a value 0, so you get B dash. Okay? And if you look at the second group, you can see A value which is 0, which is not changing. And C value is also not changing. It has a value 1, so you're not priming it. Okay? It's C, not C dash. Okay? So we have these two terms, and we have to write the addition of these two terms as the final answer. And the next expression, A dash B dash C, so since it has 0, 0, 0, we make this cell as, mark this cell as 1. And here A dash B dash C, 1, 0, 1. So it should be 1. B is 0. And C should be 0 again. Sorry, this is incorrect. A dash 0, C1, B1, 0, 0, 1, 0. This one. So likewise, you can fill out the other terms. So you'll end up with having something like this. Now here is a situation where you can consider this as a cylinder. Okay, assume that you combine these two edges, which has these arrowheads. You combine those two edges, and then you see this, you can put these 4 variables into a single group. So you satisfy the corresponding rules. You can form few groups as possible, but which are large, also large as possible. So you can put all the 4 terms or all the 4 ones into a single group, thinking that way, like a cylinder. Okay. So these are adjacent cells. And when you consider this as a cylinder, this is also adjacent to this one. That's why we can make it. Okay. So actually this should be not here. So if I draw something like this, should be much, yeah. So this cylinder, okay, you don't consider this one, this is initial values, no? When you make a cylinder, you can see that these 4 values can be included in a single group, okay? If you make a cylinder like this. Okay, so since these 4 are in a single group, so we can see what are the values which does not change, and remember same. So the A value is changing. If you look at the B value, it has 0, 0. Sorry, B value is 0 and 1. It changes. For C, we have 0 and 0. So C has a value 0 which does not change. So we write C dash as the simplified form. So the simplified form of this very big equation is now C dash. Okay. Any problems? Any problems? No? So let's go to the next one. Simplify f equals a dash b c dash d, this one. This is again, this has 4 variables. It will teach you about grouping. Give me a few minutes to fill out the table and then let's discuss. Okay. So here, I think this should move to here, okay? This should move to here. So here this is a situation where there's a one value left, okay? So that is actually what you have to learn here. So when you're grouping, you can't put this one into a group. So then you can keep this separated like this. So what is common here? You can see A value is changing and B value is not changing. Here also C value changes, but D value not changes. So BD is the common mean term for this group, big group, large group. For the other one, so everything, I mean, there's no two variables, there's only one variable. So you can write the corresponding mean term, A dash, B dash, C dash, D dash. Okay. Then write the sum of the products in writing sum of products form. So it would be something like this. And there's another problem where the function is not given for the simplicity. And you can see here, there are some values given. So try to do the grouping, and keep in mind you can make this as cylinders in both ways. Think as cylinders, vertical cylinder and horizontal cylinder, and come up with the solution which has less number of groups, which are large, and it could be overlapping. Have done the groupings. So then write out the corresponding min terms as well. So it should be something like this again. Okay. So here you can make two groups, thinking as a vertical cylinder and a horizontal cylinder. You can keep these four values in a single group. These four values in a single groups, and these two values in another group. So there are only two groups here. Okay. So these two in one group. So these four in another group. So what is common in these two? So you can see A value is 0, B 0 and 1, and B value is 0, 0. So B, and if you look at D value here, C and D, it is 0, and for C you have 0 for both, and D you have 1 for both. And when you consider these four, again you can look at what is not changing. So here B is not changing, and D is not changing. So you can write the corresponding terms at these two variables. Okay. So it will be B dash because B has a value 0. Okay. So can you do possible groupings of these? Hurry up and write down the answers. Maybe I'll give you 1 minute. We don't have much time. I need to finish this topic today. So the groupings would be like this. So here you can see you can make 3 values in a one group, 3 elements in a one group. So you can't group these 3 in a single group. And here also you can make a single group. So what you can do is actually you can group 2 here, and another group which would overlap this. Okay, you have to try to include elements into groups of 2s, 4s, 8s likewise. Okay. It's not good to keep this alone because there's one adjacent. Okay. Here also you can do the same. So the 2 possibilities you can see, either you can group this one with this one or this one with this one because there are 2 adjacencies, and you can write the corresponding answer expressions. So, so now if you are looking at K-map for product of sums expression, so we have to consider squares of the K-map such that the corresponding sum terms gives logic 0. Okay, so you have to form groups of adjacent 0 squares as possible, as we have done before. When you are simplifying the groups, variables which take the same value 0 within every square are taken as they are, but variables which have logic 1 are complemented. Okay, so opposite of what we have done with mean terms. So you have to represent the following Boolean expression to K-map and simplify it. So this is the first expression. Not as before, now we are putting zeros. Previously we put ones, and all the things are opposite now. Okay, so now we have A. Previously we put 1, now we put 0. We put 1, again 0. Okay. Sorry, 1 isn't it? One here. So we should find 0, 1, 1, 0, 1, 1 and put 0 here. We are not putting 1 because now we are considering max terms. Previously we considered min terms. Okay. Don't confuse. Same thing we are doing using max terms. We are trying to simplify this expression using max terms. Okay. The same map, initial map we use. However, the terms, you have to be careful when you are marking the terms. You do the opposite, which you have done to done in mean terms. So here we have A dash, we have so 1, B 0, C 0. A is 1, B is 0, C is 0 here. So we have 0. So likewise, you have to mark all the terms using zeros and then do the groupings. Okay. And now when you're writing the terms, grouping is same, it does not change. And now when you're writing the terms, you have to be careful. So you have to find the common terms again here also. A is common, but A has the value 1. So we write A dash, not A. Okay. Keep that in mind. We do the opposite what we have done. Instead of dot, we use plus. And C is also common. C has the value 0. So we use C, not C dash. So likewise, you can write these two and you get the end of these two as the final expression. So what's the final expression? A dash plus C within brackets dot B dash plus C dash. So this is the final expression. Okay. Product of sums. Okay. So so that's how you can do this. You can do the same for the second one also. So I think now you can do that by your own. This example. So the other thing we have to discuss today is don't care conditions. Okay. So in with this Boolean expression, what does it do? it describes the behavior of logic networks. So it gives you the output of a logic network. So, so each square of K-map would represent the response of the network. So this, what are these terms say? It says something about the response. If this combination is there, A is 0, B, C are 1, 1, the output would be something like this. Okay, so the output something which is this. So like, so sometimes it can contain input combination that never occur because you know these logic circuits, they are not virtual things. They are real physical devices. However, it would not work for something input combination, some input combinations. Okay, so those input combinations are called don't care conditions. We don't care whatever the value is there, okay, because it does not occur in that particular hardware device. So we can represent those don't care conditions by a dash or a cross or letter D. Okay, so they are known as don't care condition, dash or X or letter D. So you can assume either as 1 or 0. I mean, when you are do groupings, you can consider these positions as 1s or 0s as desired. To make your group bigger, you can use that for that purpose. And any one of such square or some of them may be included or may not be included while forming group. That doesn't matter. So here you can see the don't care conditions are marked with D. Okay, so you can you can make groups considering these things into your purpose. Okay, so let's see how you can group this. You can consider this D as one here in this 4-item group. Okay, you can consider this D as one when you are forming this group with 4 items. Okay, so that's I mean depends. So you can either consider it or not consider it. This D is not considered, you can see. This D is purposefully considered because you want to make a group of 4 items. Okay. And here this side also, you can see D, so this is a max term form. Okay. And this is the min term form. That's why ones are considered in the groupings. And that's why zeros are considered in the grouping here. Because here you consider max terms. And we make the groups and we now write the corresponding terms. So when you're writing the terms, you can see you can just consider it as 0 or 1 here. Does not matter. So that's it. So I will end up the lecture from now. If you have any problems, you can ask me. I'll make this video also available for you to look anytime. See, there are 2 chat windows. No, madam, I don't know. Maybe I may have corrected it or not. Okay. All right. Any problems? Or may I stop the lecture now? Okay, I'll upload the slides and also the video of the previous lecture is uploaded now. Okay. So not in the LMS, however, it is in the YouTube mainly because the size is quite big. It cannot be uploaded as a very big file since it's the big file. So I'll make this available, also make this also available and put a link there. So if you have any problems, please let me know and I will try to provide the solutions. And do the past papers. Now you can do up to 2 questions. 2 or maybe yeah, nearly 1.5 full 1.5 questions. More in most fast papers. So have a look at that and try to do the questions in the past papers. And I'll try to provide you a tutorial or a quiz. I could not do it last week, but I'll try. Okay, so have a good day.